All right, let's finish up this lesson. All right, so the last part we have is integration by parts, which is given by the formula right above. The integral of u dv will be equivalent to u times v minus the integral of v du, or voodoo. Okay. We use integration by parts when an integral is too difficult or impossible to integrate with standard formulas. If u and dv are chosen with care, then the integral may be easier to integrate. Okay, so this is made for integrals that you cannot apply substitution for. So here, if we try to use the substitution method, it would not work, right? It would not work. Okay, and the reason it wouldn't work, well, let's say that we wanted to make u 5x, right? Then du would just be 5 dx. So the only thing you would have covered here is just dx, nothing else. You'd still be left with this 4x, right? So substitution wouldn't work there. Substitution wouldn't work if you chose e to the 5x either. It would not work. So what we have to do is choose u and dv carefully, right? So there's going to be, I'll make a little table over here. There's going to be a little table for a derivative. And then there's going to be a little table here for the integral, or the antiderivative, right? For the antiderivative. Okay. Now this is where we're going to choose u and dv. So u should, the choice you should make for u should always be the easiest choice of the integral. So if you're looking at this integral, what looks easy? 4x or e to the 5x? And if you said it right, 4x is the easy part of that integral. It's the easy looking part. So for this one, we let u equal 4x. Now we need to make a pick for dv. So dv is always the complicated part of the integral. Most of the time is the complicated part. So for dv, well, the most complicated part of this integral looks like it's e to the 5x. Okay, now let's do what our columns say. Let's take the derivative of 4x and let's find the integral of e to the 5x. Let me zoom in a bit. So the integral of u is du equals 4 dx. Did I say integral or the derivative? The derivative, right? Then the integral of e to the 5x, so remember that this uses a special formula. The integral of e to the ax dx is 1 over a e to the ax, right? We've seen this before. So this means that dv, since we're taking the integral, the antiderivative will be 1 over 5 e to the 5x. Okay, so we are now ready to follow the formula above. So u dv is going to equal u times v. So what we do is we take, it's a good color, that's fine. We take u, oops, and multiply it by v. That's the first start. So that's u times v. So we say u times v, and I'll write it over here. All right, so this becomes the integral, oops, not the integral. First is u times v. So this becomes 4x times 1/5 e to the 5x. This was u times v. U times v. Okay. And then we're going to subtract the integral of v du. So we take v on the right side and multiply it by du, or we say voodoo. So this will become v, which is 1/5 e to the 5x times du, which happens to be 4dx. And again, this was v, and this was du. We're just following the formula, that's it. Okay, now let's clean it up. So 4x times 1/5 e to the 5x. This just becomes 4/5 x e to the 5x minus the integral 1/5 e to the 5x times 4 dx becomes 4/5 e to the 5x dx. Okay, I'm going to clean it up one more time. I'm going to take out that 4/5. You'll have 4/5 x e to the 5x minus 4/5 times the integral of e to the 5x dx. Okay, well, all we have to do is find the integral of e to the 5x dx, clean it up, and we're done. Did we already do the integral of e to the 5x? We have. We did it up here. The integral of e to the 5x is, again, 1/5 e to the 5x. So this will become 4/5 x e to the 5x minus 4/5 times the antiderivative of e to the 5x, which is, again, 1/5 e to the 5x. Okay, one final cleanup. You get 4/5 x e to the 5x minus 4/5 times 1/5, that is 4/25 e to the 5x plus, don't forget, c. There you go. That is integration by parts, right? So for the majority of these, it is always smart. If you're ever given e to the 5x or just e to the x in general, always let e to the x be dv, no matter what. Because, again, you're probably wondering, how do I make the right choice? Well, again, that's you as the student. That's the learning process. Switch up the choices and see what happens. If you let the derivative u be e to the 5x and the integral be 4x, what would happen is that by integration by parts, you would constantly be integrating forever. It would never stop. So if you found yourself 3 integration by parts in, you might want to turn around and pick it the other way. Okay, but I guess a good rule of thumb, if you're ever given e to the x, choose it as the integral part all the time. Okay, let's try it again. All right, 2. X cubed times the natural log of x dx. So again, let's make my columns. We'll have a derivative column. And we'll have a integral column. All right, for x cubed times the natural log of x. Well, there's one thing we do not know at all, is do you know the integral of the natural log of x? And that answer is no. So for this one, it's actually going to be easier to choose the natural log of x as u. So for this one, u is going to be the natural log of x. Only because we do not know the antiderivative of the natural log of x. The antiderivative of that one gets really tricky. It's a fun one, but we're not here for that. We're here to get in and get out, right? Okay, so just listen to me, and I'm going to tell you, choose the natural log of x for the derivative part. This means that for dv, we are going to choose x cubed. Okay, now we do know the derivative of the natural log of x, and when we take the derivative, du is going to be 1 over x dx. Now we want to find the integral of x cubed. So v, the antiderivative of x cubed, is going to use power rule. It's going to be x to the 4th over 4. Let's see what happens. So let's follow the formula. This becomes u times v, the natural log of x, times x to the 4th over 4, that's u times v, minus the integral of v times du, which means I get x to the 4th over 4, there's v, times du, which is 1 over x dx. Okay. Cleanup time. Let's make this look pretty. This on the left side becomes 1/4 natural log x. Actually, oops, not natural log yet. 1/4 x to the 4th natural log x. So that's what that becomes. Minus, we have some cleanup over here. Watch this. So this is x to the 4th over 4 times 1 over x. This means that this x is going to cancel, and this 4 is going to become a 3. That's just reducing powers. So what we end up with is the integral of 1/4 x cubed dx. 1/4 x cubed dx. All right. So that means, again, we only need to find the integral of 1/4 x cubed, which means that when we do the integral, I'll get 1/4 x to the 4th natural log x minus the 1/4 will stay outside, and we will power rule x cubed, which means, again, you'll get x to the 4th over 4. Okay. Last step. I'll write it to the side right here. Our final answer is 1/4 x to the 4th natural log x minus 1/4 times x to the 4th over 4 is 1/16 x to the fourth plus c. There it is. Done. All right. Not bad. Okay. So that's integration by parts. Those are the easy ones because we only have to do integration by parts once. For the very last problem, I think we're having to do integration by parts possibly twice. So let's get to it. Oops. Okay. That would be x cubed natural log x. So, oh yeah, by that. Yeah, okay, we're good. All right. Again, you can check your work by the derivative. All right. All right, very last one, forever, okay? Some problems require you to use integration by parts multiple times. We repeat until we produce a simpler integral. Okay, so there it is, the integral of x squared e to the 2x. This is just like the very first one. So remember that if you're ever given e to the x, make sure that's under your integral. Make sure that's your dv. So here we go, let's label some stuff. All right, so we'll have the derivative column. And then the integral column. For my derivative, we're going to let u equal x squared. For my integral, we're going to let dv equal e to the 2x. All right, and now derivative, du equals 2x dx. Integral, v equals 1 over 2 e to the 2x. Okay, let's write our new integral by parts. So this will become u times v x squared times 1/2 e to the 2x minus the integral of v du. V is 1/2 e to the 2x times du, which is 2x dx. Okay, let's clean this up. This is 1/2 x squared e to the 2x minus, on this one, the 1/2 and the 2 will cancel, which then leaves me with the integral of just x e to the 2x dx. Okay. So what happens here is that since this is the integral of x e to the 2x, we have to do integration by parts one more time. So we integrate by parts one more time. Integrates by parts again. Integrate by parts. Uno mas. One more, right? All right. So we'll set it up again. You'll have your derivative column, and then my integral column. And again, I will choose my u will be x, and my dv will again be e to the 2x. take the derivative, du equals 1 dx. V equals 1/2 e to the 2x. And let's set this up again. All right. So we get 1/2 x squared e to the 2x minus, I'll put a big bracket here for neatness. And here's where we do integration by parts. Again, we do u times v. So x times 1/2 e to the 2x minus the integral of v du, which is 1/2 e to the 2x times 1 dx. Close fancy bracket. Oops, too ugly. Okay, so now let's make things look pretty. I'm going to distribute this negative to all of them. So I'll have 1/2 x squared e to the 2x minus 1/2 x e to the 2x plus 1/2 times the integral of e to the 2x dx. We're almost there, guys. All we need now is to find the integral of e to the 2x, and it's done. We'll be done forever. Okay, so I get 1/2 x squared e to the 2x minus 1/2 x e to the 2x plus 1/2 times the antiderivative of e to the 2x, which we've done twice already, which is 1/2 e to the 2x. Okay, one last simplification. And we get 1/2 x squared e to the 2x minus 1/2 x e to the 2x plus 1/4 e to the 2x plus c. And that is the last calculus problem for Business Cal. You are welcome. Woohoo! Shoot off fireworks, do other fun stuff, right? Where's my magical colors at? Oh, here they are. Cosmic stuff. Yeah, look at that. There you go. Last problem there. All right, that was integration by parts. No more, no mas. No mas torture, kids. Okay. That is it. That was what, 13.3, I believe? Integration by parts. See y'all later.